All right. I'll take 1 second here really quick. Okay, cool. Yep. Hello to all of you that joined. Um, I am Alejandro. I'm a smart contract triager at Immunify, also known as Unsafe Call on Twitter. So today, I'm going to talk a little bit about this new tool that the triaging team from Immunify has released, which is called POC templates. If you haven't gotten some background on what those are, I highly suggest reading our article. Gives some background on what it is, why we created it, and what we intend it to be. And also check out the GitHub repository. But if you haven't, I'll give you a quick overview on why we have this, what is a POC, and why you should use this and also potentially contribute to the community. Yeah, cool. Let me get my Discord chat up here so I can make sure I'm answering all your questions. Definitely leave questions if you guys have them. If you already looked at this and have some questions for us, put it out in the chat. But if you have any questions during the talk, also put that in there. I'll try and look over and answer all the questions that you guys have. Cool. If you aren't looking at my screen, I am sharing my screen. This is the Immunify POC template. First of all, I'll start off with what is a POC. So POC stands for proof of concept. And to Immunify, what that really means is runnable code that demonstrates that a bug / vulnerability and impact are real without actually exploiting the vulnerability in a live environment. So this is something that should mimic on-chain state and demonstrate the vulnerability that you found in a local fork, so that there's concrete evidence that something you found is true. There can be a lot of back and forth if the bug report that you submit doesn't have a POC, because you start to get into the theoretical aspects of it and all that. But if you have a POC, if you have runnable code that you can go to a project and say, hey, if you run this, all your liquidity is going to be drained, and here it is. You can see these console logs. This is exactly what's happening. That helps a lot in getting in explaining your vulnerability to a project and eventually getting paid. A POC is the item that most hackers have trouble with, but is required by most programs on Immunify. And what POC templates aims to solve is help our security researchers and researchers in the space in general create a POC that shows that real world impact faster and in a more standardized way. Right. So what we've seen is there's a lot of duplicated work that ends up happening because there are a lot of similar attack vectors in the space. Things like reentrancy, price manipulation. There ends up being this duplicated work that isn't maybe core to the vulnerability itself, but is a necessary step in executing a vulnerability. Another example of that would be flash loans. Sometimes an attack can be very capital intensive, and projects may disregard this if you have to spend like hundreds of millions of dollars. They're like, an attacker may not have access to this. However, through flash loans, if the attack can be done in a single transaction, you don't need any starting capital to take a flash loan and execute the attack on a certain protocol. So to be able to um, show a project, hey, there is actually a way for an attacker to get this much capital and it would cost them nothing or a small fee, then we can really you can really get some leverage there because this all exists in the ecosystem already. Okay, so I'll get into some of the templates that we provide, and I'll just talk a little bit about this. But one more thing I want to touch on is, another really important aspect, at least to me, when I'm doing research, is concentration. So there have been plenty of times where I'm researching a bug in a protocol, but then I have to get pulled out of my train of thought because I have to research, how this other lending protocol works or how I take a flash loan for a POC. And that hour plus of time I've spent like flipping back and forth between a staking contract and governance and keeping everything in my head, you know, that can all get just thrown out the window if I break my concentration to go and read another protocol's documentation. So another thing we're trying to solve here is we're trying to abstract away some of these protocols which may be necessary to demonstrate an attack but aren't core to the vulnerability itself. So these templates are targeted towards like mid-level to advanced hackers, but those of you who are just starting or just learning, I'll talk a little bit about how you can, get involved and level up your skills later, and also contribute to the community by contributing to this repository. So let's get into it. So this POC templates, this is based on Forge, which is a smart contract development framework. Forge is a prerequisite, but why we like Forge is you can write tests in Solidity. So you're writing code in the same language that the smart contracts are written in. So you're not having to juggle two different languages. And honestly, I hate dealing with big numbers in JavaScript. So I love Forge. So some of the templates that we provide in this repository right now is reentrancy, token balance manipulation, flash loans, and price manipulation. So what these are a set of extendable contracts that your POC can extend and gain access to functionality that we've written to make it a lot easier for you guys to do these things. So for example, let's take a look at the flash loan example. Or actually, let's go to the README. Let's go to the flash loan README. So in this README, you'll see a list of networks which we support flash loans on. And you'll see an example of the usage. So what this flash loan module lets you do is take a flash loan with one line of code. You don't have to think about the underlying protocol. You don't have to think about swapping, your synthetic token or anything like that. All you have to do is call take flash loan and pass in one of the providers we have a library for. So if we go back up to the networks, if we take a look at Ethereum, these are all the protocols that we support flash loans for. And the way we're going to use this, we'll take a look at the flash loan example, is just this single line here. Take flash loan. We're passing in the flash loan provider. So this is just going to be, flash loan provider.of or flash loan provider.balancer. We're passing the token we want to flash loan, and then we're passing in the amount. And the way a lot of these templates work is when we call this function, it's going to interact with whatever provider we choose. So let's say it's Uniswap v3, It's going to interact with Uniswap v3, take that flash loan, and Uniswap v3 is going to call back into our contract. So what that means is after we call take flash loan, function execution will go to execute attack, which is called on these flash loan callbacks. And then this is where we're going to do whatever we want with those flash loan funds. Yep. Please let me know if you guys have any questions. I feel like I'm going a little faster. Anything you guys want me to maybe dig into more, please let me know. Yeah. So another really cool thing about these flash loans are they automatically determine the chain you're on and update those addresses for the protocol automatically. So you don't have to concern yourself at all with what chain you're on when you're using these flash loan utilities. As long as there's a provider available, it will automatically change the context based on the block.chain ID. Cool. So yeah, so the basic structure of these is there's a folder with the vulnerability that we created a template for. And if you go into there, there'll be a contract which is meant to be extended. So this abstract contract, this flash loan contract, gives you this flash loan functionality. And some of our templates will have libraries for the different protocols we're interacting with. So for example, we have AUV v1, AUV v3, Balancer, Euler, MakerDAO, Uniswap v2, v3. All of these are just interfacer contracts that have different functionality based on how a flash loan is taken, how a flash loan is paid back, etc. So if we take a look at our flash loan provider, let's take a look at the callback. Or sorry, let's take a look at flash loans. Take a look at the callback here, the callback function. All this template is doing is it has a generic fallback function, which this fallback function. Sorry, this default fallback function here is called whenever, if you guys remember Solidity, default fallback will be called anytime a function signature doesn't match any of the functions in the contract. So we have this generic fallback to accept any callbacks from these flash loan providers. So whatever it is, it'll just get redirected to this fallback function. And in this fallback function, we're executing the attack, we're calling execute attack. And then if we have called to one of these flash loan providers to take a loan, that's what this is. This is just the flash loan provider call stack. We're going to check if the function selector is the provider's callback. So for Uniswap, I think this is like on swap or something. I think the standard's now like on flash loan. So we're checking the function signature matches that by taking that message data. Just to make sure we've already called out to the provider. Yeah, so if this is from the flash loan callback, then we know we've successfully completed this attack. And then here we also pay back the flash loan. And then here there's some funky stuff going on with return data because some flash loan callbacks require return data as well. But yeah. I'm explaining this to you guys so you get an understanding of kind of how these templates are written. But really, ideally, you don't even have to think about that. In our flash loan templates, you can see right here, all you have to do is call take flash loan. And you don't have to worry about any of those things that I just talked about. You just have to worry about having enough capital to repay that. Okay. Um, yeah, something else that I found myself doing a lot and we added into these templates was common token addresses. So I found myself, going to Google and searching USDC Etherscan or WETH Etherscan or etc. Like I did that all the time, and I would copy and paste addresses all the time. So what this template gives you is the top 50 tokens from Etherscan or whatever Etherscan like block explorer for the respective chain. So we have all these tokens that you can just reference by the token name. And these are wrapped as ERC20 objects. So you can directly call like transfer approve without having to wrap it as an ERC20 object. So let's take a look at the tokens. So we did wrap Forge. Forge is native functionality of Deal, which is a cheat code and lets you change the balance of any account. We basically just wrapped the Forge Deal function to accept the ERC20 object. So it makes it a little easier to pass in these tokens. So all you have to do if you want to have access to the top 50 tokens on Ethereum is you import this tokens contract and you reference them by the library name. So Ethereum tokens.eth, Ethereum tokens.usdt, so on and so forth. Okay. I am going to skip price manipulation and reentrancy for now. I'm going to show you guys how to get started using this repository. There's two different ways actually. But yeah, I'll move on to some my VS Code window. Show you guys how to get started. Okay. So the first and probably easiest way to use this repository is just to clone it. So if you clone the repository, you're going to have all these files and same environment as the repository itself. And yeah, so first step is Foundry installation. Second step is picking a POC template. So in this source file, there's going to be these template files. These are intended for you guys to modify for your attack. So these are just here as examples. So if you wanted to create a POC with flash loan, you go into this flash loan template and you can just modify it. And there's already a test created for it. So this flashloan.t.sol is the test for the flash loan template. And this is just like an easier way, since you already have the test set up, you can just run forge test and then -- match path. Yeah, so these templates were intended for you guys to modify for your POC. The second way to use this repository is to actually install it as a dependency through Forge. So here, really quickly, I'll go ahead and make a new folder here. Okay, so we have an empty directory. I'm going to run Forge init, start a new Forge. Okay. Let's go ahead and change over to that workspace. POC example. So right here we have a clean Forge project. And all you have to do to include the POC templates as a dependency is Forge install, and then the name of our organization, Immunified Team, and the name of the repository, Forge POC templates. So if we go ahead and do that, we're going to get these POC templates in our library. So this repository is in our library here in our Forge project. And then when we're writing our POC, we'll just import, we'll import only the vulnerability classes that we need. So if we take a look at this, the source, if we want to extend the reentrancy template, we'll import this Solidity file right here. So I guess I'll just go ahead and show that. Let's add a remapping. Let's change this to like POC templates. And this will point to our library. Oh, I put too much here. Let's take that. Okay, so templates. Forge POC templates. Yep, that looks right. Uh, okay, why do we have a problem here? Let's see. Ah, okay. I think I'm missing an S. Right. Okay, cool. So yeah, so we can import our reentrancy contract, and then our attack contract will extend the reentrancy contract. So what does this do? Well, you're going to get a couple errors when you try to compile this because the attack contract needs to implement certain functions that the reentrancy abstract contract expects. So this is like execute attack and complete attack. So if we take a look at the abstract contract here, we can see there are these internal functions which it wants you to implement. And it wants you to implement because with a reentrancy template, we define all of these common callback functions. So you can see here, this handles the receipt of ERC 677 tokens. This one's for ERC 1363, 115. We have 721s in here. All of these call this standard reentrancy callback function. And this reentrancy callback function calls execute attack. So yeah, so this is going to handle all of the callbacks for you, and all you have to do is implement this execute attack function. Okay, let's go back to our template repository. Right. So if you chose to modify a template instead of installing it in your new Forge project, we already have the tests set up. So all you have to do is run Forge test, and we'll do some logging here. Dash VV, we'll put uh, two V's, and then we're going to match path. And then this is going to um, take in the test file, which we want to run. So if we're testing our reentrancy template up here in the source, we're going to run our reentrancy test down here. So test slash reentrancy. And yeah, there's some, I'm in the wrong directory. Okay, cool. So yeah, that ran our reentrancy test. Um, you want to make sure if you're submitting this as in your report, make sure you include how to run your POC. That's pretty important. Um, because there are a few test files in here, and yeah, you want to make your work as clear as possible. Marguerite, I'm getting some noise from your mic. Okay, cool. Um, so I think I'm going to open up the floor to questions here. While I remember if there's anything else I wanted to talk about here. But really, I totally forgot. For those of you who are learning, I told you there would be, I would let you know about how to get involved and how to, level up your skills. So in our repository, we have a POCs folder, which are POCs that are created using our templates. So if you're interested in learning or you're interested in contributing to the community here, a really good way to do that would be to go through some of our Medium posts, some of our hack analysis or bug fix reviews, and basically convert that POC to use our templates. So what that will do is get people to using the templates and figuring out what works, what doesn't work. If you have an issue, open up a new issue in our GitHub repository. There's a discussions area where we can discuss new features. If you find something that you think would be good to have but isn't there, definitely feel free to request any features you see fit, and definitely report any issues you run into. Yeah, so if you're just starting out, recreating those POCs would be a really good way to start to get to wrap your head around how you might write a POC for a vulnerability you find. And hopefully using these templates, it'll be a lot less, daunting of task. And for those of you who are more advanced hackers, hopefully this just saves you time. Because honestly, time is a huge factor, especially if you're a independent researcher, independent bug bounty hunter. Really where you invest your time is really important, as much as the skills you have. I see someone said RPC URLs default to Anchor. Yes, we default to Anchor's public RPCs, and that way tests work out of the box. Okay, so I don't see any new questions, so maybe I'll just talk about the price manipulation a little bit. So this price manipulation template lets you manipulate the curve pair price. So this vulnerability was used in a couple instances of read-only reentrancy, which is pretty interesting. Yeah, right now we currently only have the curve price manipulation, but we're looking at adding more protocols, which may have vulnerable oracles. Yeah, our reentrancy template. You can take a look at all the callbacks that we implement here. And you know, these four vulnerability categories, you know, this is just the beginning for our POC templates. We definitely have vulnerability classifications that we have in the pipeline. We wanted to release this as quickly as possible to get it out to you guys, to get some feedback, to get some ideas if you guys would have thought of some other vulnerability classifications that you would have liked to see here. Definitely let us know. But hopefully you guys can use these templates to save you time and to learn as well. Okay, Pepin, is there anything you think that I should cover, or maybe any questions I may have missed in the chat?
The only question left, I think, is if it's possible to simulate transaction of which you don't have the private keys in Foundry.
Private keys. Oh, yes, definitely. So there's this cheat code called vm.prank, and that allows you to simulate sending a transaction from an account that you don't have the private key of. So I think it's like vm.prank. You pass the address, the public address of the account you want to emulate, and then right after you call whatever function you want to as that user or as that address. Cool. Yeah, so these these POCs definitely contribute to. We're adding these community POCs to our README, and we're tagging your Twitter here, so it'll be a good way to get your name out there. We do have an LGPL v3 license, which means you have to sign a CLA before we can merge your contribution. But you can sign with your screen name. That's fine. We just need you to accept the terms in there. As far as a sneak peek on the future of the POC templates, we would really like to have a command line tool which allows you to really quickly set up a repository with all of the dependencies, all the contracts that you'll be interacting with, potentially download transaction data that you're creating a proof of concept for the sandwich, things like that. So keep an eye out for that. And also just keep an eye out for new vulnerability types that we'll be adding to this repository. Okay, cool. I think that's it for me, Pepin. Uh,
I think that's great for everyone to start working with the repository. Thank you, Ale.
yeah, of course. Yeah, definitely. If you have any more questions, I'm more responsive on Twitter. I'm not on Discord super often. So feel free to reach out. Um, if there's issues, don't be afraid to open up a conversation here in the repository. Um, and yeah, we want this to be, an open and collaborative tool. And the first step in that is having a community. And you guys are a great community to start with. So um, definitely, if you're looking at getting into smart contract hacking, try and participate or trying to participate in something. Um, take a look at the repository and add suggestions, things like that.
Seems like no one has any more questions, so thank you so much. And yeah, we have some minutes left, but if anyone, yeah, no one has any question. So thank you so much everyone for coming, and thank you Ali for explaining us the repository and how to use it.
Yeah, of course. Thank you.
See you everyone. Thank you. Bye.
Y'all.